Okay, here's the video number 2, and on this one we're talking about the mean or expected value using those probability distribution functions. The expected value is often referred to as the long-term average or mean. This means that over the long term of doing an experiment over and over and over, you would expect to get this number. The law of large numbers states that as the number of trials in a probability experiment increases, the difference between the theoretical probability of an event and the relative frequency approaches zeros. So, what I actually would say is the theoretical probability and the experimental probability end up being the same. Okay? So, theoretical and experimental, it pretty much disappears when you're dealing with large numbers. When evaluating long-term results, we often want to know the average outcome. And you get it. It is denoted by the Greek letter mu. Okay? You would expect this average value. That right there is called mu. Okay? All right, a men's soccer team plays soccer 0, 1, or 2 days a week. The probability they play 0 days is 0.2. The probability they play 1 day is 0.5. And the probability they play 2 days is 0.3. Find the long-term average or expected value, mu, of the days, the number of days per week the men's soccer team plays soccer. So, number 1, to do the problem, first let that random variable x be the number of days the men's soccer team plays. And that again is in words. And we had on the values 0, 1, and 2. 0, 1, and 2. So your probability for 0 is 0.02. Probability for 1 is 0.2, sorry. 0.5, and 2 days is 0.3. X times P of x. 0 times 0.2 is 0. 1 times 0.5 is 0.5. And 2 times 0.3 is 0.6. So, the second thing that you're going to do here is get your values, 0, 0.5, and 0.6, and add them together. You add the last column there, and you get 1.1. So the expected value is 1.1. And you would write that mu equals 1.1. Okay. Why casinos make a lot of money. This is why the lottery makes a lot of money. Suppose you play a game of chance in which 5 numbers are chosen from the digits 0 through 9. A computer randomly selects 5 numbers from 0 to 9 with replacement. So you can get any one of these every single time. You pay $2 to play, and you could win $100,000 if you match all 5 numbers in order. You will get your $2 back plus the $100,000 you win. Over the long term, what is your expected profit of playing the game? Let x equal the amount of money you profit. The values of x are not 0, 1 through 9. Those are these are these choices, but they're not the values. Since you are interested in your profit or loss, the values of x are 100,000, which is your win, and a -2, which is your loss. Now you need your probability of x. These x, the little x, equals -2 and $100,000. That's it. They don't equal anything else. Your probability here is 1 chance out of 10 of getting it right. Okay? There's 10 digits. You have 1 chance. Times 5 would be 1/10 to the 5th, or 10 to the -5, which is 0.4 zeros and a 1. So the probability of winning is 0.00001, and the probability of losing is 0.99999. Okay? So, we wrote that up here so you would know where it was coming from. Your loss, your X, -2. Your profit, 100,000. Those are your values of X. P of X, we just found out. Okay? So, when you multiply them out, you get -1.999998. Okay? Roughly a -2. Looks -2. And 100,000 times this gives you 1. So, if you add these two together, -2 plus 1 is a -1, which means you would lose approximately $1 for every game you play. Okay? That is your expected loss per game after playing this over and over and over. Okay. You are playing a game of chance in which 4 cards are drawn from a standard deck of 52 cards. So, 4 cards are drawn. You guess the suit of each card before it is drawn. They were placed in a deck on each draw. You pay $1 to play. If you guess the right suit every time, you get your money back and 256. What is your expected profit of playing the game over the long term? Okay. Well, our two X values are loss of $1, you don't win, or a profit of 256. Your probability of this happening is found from the first sentence. 4 cards are drawn. You've got the suit. There are 4 suits, hearts, diamonds, clubs, and spades. You've got 1 chance out of the 4 of getting it correct on each draw. So, this right here gives you 1 over 4 raised to the 4th, 256. So you have 1 chance out of 256 to profit here. Okay. Normally people will put that into decimals. I'm not, simply because I got the 256 here. When you subtract that, though, 1 minus 1 over 256, you get, let's see, 1 divided by 256 is 0.0039. I could do that, 0.00390625. Okay, so 1 minus 0.0039625 equals 0.9960375. Okay. When you are multiplying these things out, you're going to have -1 times this, which will give you -0.9960375. And 256 times 1 over 256. Now remember when we were doing the trig identities? And I said it was just like your numbers used to be. 1 on top, 1 on the bottom to cancel out. So, I would have 1 minus 0.9960375 0.99603 Should be -1. Okay. That actually, right there, gives me 0.0039 65. I must have put something in wrong. I did put something in wrong. I needed a 9 here. 375. Right before there. That's where I went wrong. So 9375. When you have +1, okay, it comes out to right, when you add that up, you do get exactly what we've done, which is right back up here, 0.0039065, which is basically 1/256th of a cent. Okay, so pretty much as close to 0 as you can get on this. But you don't win anything. So you just kind of stay at 0. But this is long enough. I will start the third.